All. In today's lecture, we are focusing on ultrasonic machining. In last two lectures, we will discuss on abrasive jet machining, water jet machining, and abrasive water jet machining. In today's lecture, we will discuss or focus on ultrasonic machining, which is a mechanical energy based non-conventional machining process. Now, in abrasive jet machining, we see that material is to be removed by using the abrasive particle. In water jet machining, material is to be removed by using the water, and in abrasive water jet machining, we are utilizing abrasive water jet for the removing of the material. Now, in this lecture, we will discuss on ultrasonic machining. In ultrasonic machining, we have utilized the use of vibration energy, that is the high frequency low amplitude vibration we have to utilize for the movement of the tool, and abrasive particle slurry, it will be passed between the gap of tool and the workpiece in order to remove the material from the workpiece. The vibrations are given to the form shape tool that will push the abrasive particles in abrasive slurry against the work surface so that the material is to be removed from the surface of the workpiece. In ultrasonic machining, this one is a non-traditional machining process grouped under mechanical energy. It is employed to machine hard as well as brittle material, and these materials are electrically conductive or non-conductive also. Ultrasonic machining uses shaped tool, high frequency mechanical motion, that is vibration, and slurry of the abrasive. In ultrasonic machining, material is to be removed by the abrasive rays, which are driven into the work surface by the tool oscillating normal to the surface of the workpiece. Now, when we are discussing the working principle of the ultrasonic machining, this will be the transducer. It will give the feed motion, which transfer motion is given to the tool against the horizontal surface of the workpiece, and the tool is the form shape tool. The tool is mounted in a tool holder, and this tool holder is provided with a transducer, and this transducer, it will generate the ultrasonic vibrations which are having a frequency near about 20 kilohertz, and that will be the high frequency with a low amplitude within a range of 15 to 50 microns. When this tool is vibrating because of a transducer, the abrasive slurry, that is a mixture of abrasive particle and liquid, it is passing in between workpiece and the tool. When this transfer motion, it will be applied against the workpiece, the sharp edge abrasive particles, they are pushed against the work surface of the workpiece, so that material is to be removed from the upper surface of the workpiece, and after use, that part is flushed out by using this abrasive slurry. In working principle of the ultrasonic machining, a tool of desired shape that will vibrate at an ultrasonic frequency near about 20 kilohertz with an amplitude of 15 to 50 microns over the workpiece. Generally, the tool is pressed downward with a feed force, and between the tool and the workpiece there will be machining force, which is provided with the hard abrasive particles, generally in the form of water-based slurry. As the tool vibrates over the workpiece, abrasive particles act as indenter and indent both the work material and the tool. The abrasive particle as the indent the work material would remove the same. Means because of abrasive particles, as abrasive particles are the sharp particles, it may cause the removal of the material from the workpiece as well as from the tool because of the indentation. This is the working principle of the ultrasonic machining. Now what are the equipments they are used in ultrasonic machining? There are four equipments or elements of the ultrasonic machining. Transducer, that is the magnetostatic transducer, is used to generate the ultrasonic frequency. Then tool holder, it will utilize to hold the tool with the connecting body with the transducer. Tool material and tool size, depending upon the type of the material we are using for the machining. By considering the material of the workpiece, the material of the tool and the size of the tool, it will be decided. And last one, that is the abrasive slurry, because tool is not removing the material from the workpiece. Whatever the abrasive particles those are present in an abrasive slurry at the machining gap between tool and the workpiece, that abrasive particles are responsible for the removal of the material from the workpiece, and the material is to be removed in the shape or form that the tool is having. That is, the form shaped tool is utilized in case of ultrasonic machining. Then there are different process parameters that must have to control while carried out the ultrasonic machining process. First, we will consider the amplitude of vibration. Whatever the vibration amplitude, it should be low, as low as possible. It will be between, as we discussed, 15 to 50 microns. Whatever the frequency of the vibration, it will be up to 25 kilohertz. We have to give certain feed force to the tool in order to remove the material from the workpiece. To apply the feed force, we require the feed pressure. There are certain strength or flow or feed is given to the work material as well as the tool material. The contact area of the tool, it also affects the rate of material. Next, that is the size of the abrasive. Right? Abrasive may have various sizes. Depending on a particular application, we may select the particular size of the abrasive. The type of the abrasive material, it may be aluminum oxide, silicon carbide, boron, silicarbide, and diamond. It may be selected based on application. The volume concentration of the abrasive in water slurry means how much amount of abrasive you have to add in a water in order to produce the abrasive slurry. It is also important. The slurry in which we will use the abrasive. That abrasive, how will be selected? By considering its hardness, its size, its quantity, and the flow of the abrasive. And how the liquid is to be chosen? By considering its chemical property, its viscosity, its flow rate. Means slurry, it is a combination of abrasive and liquid. But while forming the slurry, the abrasive and liquid, its selection is very important. Another parameters, those are related with the tool and work material. While selecting the tool, we must have a think about the which material you have used for the tool. What will be the shape of the tool? How much amplitude and frequency of vibration you have applied, and how much strength is to be developed in the tool. That parameters must have to consider while selecting a particular tool in ultrasonic machining. Last one, that is related with the work material or workpiece. Which type of the workpiece you have to use to remove the material from that workpiece. How much is its impact strength? How much is the surface fatigue strength? That must be considered while selecting a particular workpiece in an ultrasonic machine. Now there are certain effect of process parameters on material removal rate. If we are considering the first parameter, that is the frequency, its effect on material removal rate. In theoretically, it will be as frequency goes on increasing, the material removal rate it will goes on increasing. But in actual practice, up to a certain extent, it will be linear. After that, as we increase the frequency, it may fall down the material removal rate. This is the first parameter, that is the frequency, its effect on material removal rate. Second one related with the amplitude. Means with the increase in the frequency, amplitude goes on increases. But with an increase in amplitude, definitely material removal rate it will be increases, as we seen in the previous diagram. This is the variation of the amplitude or effect of the amplitude on a material removal rate. Are you getting? Next, there is the variation of the feed rate or feed force, that is related with the tool. Feed force given to the tool. With increase in amplitude, the feed force it also goes on increasing, but up to a certain amount of the feed force, the material removal rate it will be increases. After that, it will tends to fall down. Means up to a certain amount of the feed force, the material removal rate it will be increases with increase in the feed force, at the same time with increase in the amplitude. The last, that is related with the work hardness to tool hardness ratio. That is hardness ratio. This hardness ratio have an impact on material removal rate. As we are goes on increasing the hardness ratio, material removal rate it will goes on decreasing. Means as far as possible, hardness ratio it should be a minimum. The mean gain diameter. This is the diameter, its effect on material removal rate. Theoretically, it is a linear proportion. As we discussed, it will be decreases with a certain optimum diameter of the mass. Last one, that is related with the variation with the concentration, abrasive concentration. Means as the abrasive concentration goes on increases, the material removal rate up to a certain level of the concentration, up to 30% concentration of silicon carbide, boron carbide, the material removal rate it will goes on increasing. Beyond that, it will tends to decrease. These are the certain parameters those are having an impact on material removal rate in case of a ultrasonic. What are the advantages? The hard material can be easily machined by using ultrasonic machine. There will be no generation of heat, so heat hardening that will be not happened. Non-conducting metals and non-metals can be easily machined by using the ultrasonic machine. That cannot be machined by using the electrochemical machining and electrodischarge machining. It does not form chips of significant size. These are the certain advantages of ultrasonic machining. Then disadvantages: low metal removal rate, tool wear rate is high due to abrasive particles, tool made up from brass or tungsten carbide, the action of abrasive grit with a ratio that ranges from 1:1 to 200:1. There are certain applications of the ultrasonic machining. Ultrasonic machining can perform different machining operations like drilling, grinding, milling. It will be suitable for piercing of dies, parting of and blanking operation. It will enable the dentist to drill a hole of any size on a teeth without any pain. Means in a dentist work, ultrasonic machining operation it is a useful one. It can be used to cut the industrial diamond, grinding the quartz, glass and ceramics. At the same time, It will be used for machining the cavities in electrically non-conductive ceramics. Large number of holes of small diameter can be machined by using the ultrasonic machining. It is used for machining hard, brittle, metallic alloys, semiconductor, glass, ceramics, carbide, etc. By using ultrasonic machining, we can machine round, square, irregular shaped holes and surface impressions. It will be used for machining of dies for wire drawing, punching, and blanking operation. These are the certain applications of the ultrasonic machining. Now we will discuss certain comparative points or comparison between the different methods we have studied in a mechanical energy system. The first comparison, it is a in between abrasive jet machining and ultrasonic machining. In abrasive jet machining, we are using the jet of abrasive particles which are having a velocity in between 100 to 300 meters. In ultrasonic machining, we are utilizing the ultrasonic frequencies which are having a range of 20 kilohertz and amplitude up to 15 microns. In abrasive jet machining, high velocity jet is allowed to directly strike the workpiece. In ultrasonic machining, the vibration is not directly imparted to the workpiece, but they are given to the abrasive particles, and that abrasive particles are imparted on the workpiece. In abrasive jet machining, we does not require any specialized type of the tool, but in the ultrasonic machining, it is mandatory to have a physical tool which is having the inverse profile of the indented shape. In abrasive machining, we require the air compressor in order to increase the pressure of the air. It does not require in a ultrasonic machining. The material remove rate in a abrasive jet machining, it will be a high, and material remove rate in a ultrasonic machining, it is a low. Abrasive jet machining can be used for the ductile and brittle material, but they must be a softer one. And in ultrasonic machining, they are commonly used for machining hard material, especially those which are electrically non-conductive ones like glass, ceramic, carbide. Abrasive jet machining produces extreme noise during the operation. This will be a relatively noiseless and safe process, that is the ultrasonic machining. In abrasive jet machining, whatever the abrasive grit after use, they may scatter out from the chamber and it may have some certain hazardous to the operator. So it will be the comparison between abrasive jet machining and ultrasonic. The last comparison between abrasive jet machining and water jet machining. In abrasive jet machining, you are using high velocity of jet of water and abrasive mixture for the removal of material. But in water jet machining, you use only pure water for the material removal. The working medium in abrasive jet machining, it is free from dust and humidity. Working medium in a water jet machining is a clean water. Here we require the air compressor for delivering the air at high pressure. In place of air compressor, here we require the pump and intensifier in order to increase the pressure on the water. The pressure of the air, it will be in a range of 2 to 10 bar in a abrasive jet machining. The pressure of water, it is in between 2500 to 4000 bar in case of a water jet machining. The velocity of the abrasive jet, it will be 100 to 300 meter per second. And in case of water jet machining, it will be around 900 to 1000 meter per second. There will be possibility of having the grid amendment in case of abrasive jet machining. After the machining, there will be no such case of the grid amendment as abrasives are offset. It cannot be used in a food processing industries because of contamination of abrasive particles. But in in water jet machining can be preferred, and it will be hygienic for slicing food items like frozen meat and fish, etc. It can efficiently machine hard material including the metals. In fact, abrasive jet machining is preferred for machining hard brittle metals and ceramics. The water jet machining does not possess enough power for cutting the metal, so it will be suitable for cutting softer material like wood, rubber, and leather. These are the certain points which will distinguish abrasive jet machining with the water jet machining. So in this way, in this lecture, we will cover working of the ultrasonic machining and certain comparative points between mechanical energy based